Okay, good afternoon. Welcome to the very last 1805 lecture for the term. So as I promised last time, there's no new content today. All I'm doing is a review of what the exam is going to be like and a brief review of what we covered in the course. So I'm not one for slides, but I'm doing them today just to save me some writing. The slides will be available on See Learn. This lecture will be on YouTube just like always. Okay, so the exam is going to be 3 hours long, closed book. There's 13 single-sided pages plus one cover page. Sometimes they trick me and they print it double-sided. I mean 13 surfaces of pages is its length. The last 3 pages in the exam are blank. You can use them for rough work. That's fine with me. The exam is entirely multiple choice, so everything you do will be on a Scantron sheet. So absolutely nothing you write on the question paper is going to be marked. So I'm going to throw them all out after the exam is over. I'm not going to look at them, so all answers have to be on the Scantron sheet. Everything else will be ignored. There's 40 multiple choice questions, and for all of them you'll have A, B, C, or D as possible answers. Don't pick E. I think on maybe 1 or 2 of them there's just A and B, so kind of a true or false deal. There's one last question, which is a bonus question. It's kind of tricky, but not too bad. If you think about it, you should hopefully get the answer. Don't attempt the bonus question until you're happy with everything else, though. Question?
Is it a bonus question like weird and like tricky, or is it just kind of like a hard 1805 question?
It's a hard 1805 question. If you've been paying attention to what I've been talking about in class and you apply a little bit of thought, you should be able to solve it. Okay, so for those who have not written a Scantron exam before, this thing on the left is kind of what they look like. I've posted the Scantron guide pamphlet thing on See Learn for you to take a look at. The way it works is you print your first and last name in the box marked first and last name. You also shade in the appropriate bubbles so that the machine can read your first and last name. You should print your student number as well as shade in the appropriate bubbles for your student number. There's a space you can put in the exam version number. There is no exam version number. You'll all be writing exactly the same exam, so you can leave that blank. The course, you're enrolled in Comp 1805B or possibly Comp 1805M. It doesn't actually matter what you put here, but I would suggest at least putting Comp 1805 just in case something happens to your test. You need to use a dark pencil. That's important. You absolutely can't use a pen. Do not use a pen. The boxes or bubbles have to be shaded fully and neatly, so inside the lines. And if you should happen to make a mistake, you need to make sure that it's erased completely. So I suggest bringing both a pencil and a good quality eraser. So that's important. It's very easy to mess up your sheet otherwise. I often get worried emails from students saying, oh, I spelt my name wrong, or I got my student number wrong, or something like that. The system isn't completely stupid, right? Your exam will be in my pile of exams, and we get a nice printout that shows us any mistakes or student numbers that aren't the right length or things like that. I'll probably be able to figure it out. At least spell your name right. That's all I ask. Okay, so we covered a lot in this course. This is a very sort of densely packed course. The first thing we looked at was propositional logic. So that was propositions, connectives, translating from logic to English, from English to logic, working with truth tables, the definitions of tautologies, contradictions, contingencies, as well as working with logical equivalences and deciding when 2 statements or propositions were logically equivalent. So the kinds of questions you would get here are something like, which of the following is a proposition? And I will list 4 things, and you will tell me which of those 4 things really is a proposition. What is a valid translation of the following proposition? So I'll give you something in logic, you translate it to English, might also go the other way. I might give you a proposition, ask what its truth value is. I might ask you to find the negation of a proposition. Or maybe the inverse, converse, or contrapositive of an implication. That would be another common one. I might ask, is a proposition, a particular one that I give you, a tautology, contradiction, or contingency? And I might ask, are the following 2 propositions logically equivalent? These are the big ones that come up here. Question?
What's the truth value of a proposition?
Right, so true or true would be true. right? I would give you truth values, how they're connected, and you say what it evaluates to, something like that. So these are the kinds of questions you'll see. You'll have to use your imagination to fill them in. So I'm not going to give a full sample exam like I did with tests, because that's a lot of work. Making a good multiple choice exam is really, really hard. So that's why I'm just giving these kinds of things. These are the questions you'll see though. Yeah?
Will there be all the above, none of the above answers?
I don't generally like to do that. Sometimes I see it, but it's not every question has those. So I have them when it makes sense to have them, just not all the time. A lot of profs do that to save themselves in case they make a mistake, just so that there's always a reasonable answer. I put in a lot of effort and have TAs check it to make sure that every question really does have an answer. I'm fairly confident when I say that there are no mistakes on this exam. So if you think one of the answers is correct, look at it again. Is there another question? Yeah?
What was that question that was just asked?
So the question was, is it the kind of multiple choice exam where there's always an E, none of the above? And the answer is no. Sometimes there might be an all of the above or none of the above, but it's not an every question kind of thing. I have it when it's appropriate to the question, not as a cop-out to make sure I'm never wrong. Okay, so after propositional logic, we talked about predicate logic. So that was the definition of a predicate, the definition of a propositional function. We talked about quantifiers, so the universal and existential quantifiers, how to negate those quantifiers, how to translate sentences using them. We also talked about arguments and validity. You could talk about arguments in the context of propositional logic too, but we mostly concentrated on the predicate case, as well as the rules of inference. Yeah?
Are the rules of inference what you use to solve arguments?
Yeah, so it's modus ponens, modus tollens, deductive syllogism, and so on.
And what's a predicate again?
A predicate is the non-variable part of a propositional function. So in this course, it's essentially the same as a propositional function. Other questions? Okay, so the kinds of questions you'd see here are, what is the negation of the following quantified statement? So you would need to apply quantifier negation. What is a valid translation of the following proposition that involves predicates or quantifiers or whatever? Is the following argument valid? Or maybe I'll give you the premises and ask you what's a valid conclusion to draw. So which of these four conclusions is valid to draw? What rule of inference has been used in the following argument? So I'll give you an argument, but I won't tell you what rules were used, and I'll ask you what rule did I use in step 5? And you'd say, oh, you used modus ponens. Another kind of spin on that would be what rule of inference has been used incorrectly in the following argument. So I'll give you an argument, complete with a derivation, but there'll be a mistake in it somewhere. And you'll say, oh, the mistake is on line 5, or the mistake is on lines 3 and 6, or something like that. That's what you would see for that. Any questions about these kinds of questions? Okay, so after we talked about predicate logic, we moved on to methods of proof. So the ones we saw were direct, indirect, vacuous, or trivial. Didn't spend a lot of time on those. Contradiction, cases, equivalence, existence, both constructive and non-constructive, as well as uniqueness and counterexamples. There's also induction, but I'm counting that as a separate thing a little bit later on. So the kinds of things you'd see here, proofs are kind of the tricky thing to do multiple choice with. So the examples you'd see here are, here's a proof, what method am I using? Maybe it's a direct proof or an indirect proof or whatever. What step is missing from the following proof? So maybe I'll give you a proof but take out a line and you would have to fill in the blank with one of the 4 options you were given. What step is incorrect in the following proof? I mean, that's like the argument one, except with a full proof. And I might give you a statement that's false and ask you which of the following 4 things is a counterexample for that statement. Does that make sense? Okay. So after proofs, we talked about sets. For sets, you need to know the definitions of things. So the definition of what is a set, what is the empty set, what is the union, things like that. Cardinality of a set, the operations you can do on a set, so that's union, intersection, difference, and so on. What a subset is, what it means for 2 sets to be equal, what power sets are, what membership tables are, what Venn diagrams are, and the different set identities, which are like logical equivalences. So I could ask you, what is the cardinality of the following set? And that's something you saw in one of the tests. Is the following object an element of the given set? That was also on one of the tests. Is the following set a subset of the given set? That was also on one of the tests. What is the power set of the given set? Are the following two sets equivalent? What set is represented by the following Venn diagram? So I give you a set and a choice of, I give you a Venn diagram and ask you which set it represents, or vice versa, right? I give you the set and ask you for the Venn diagram. Both of those would be reasonable choices, and you would probably want to make a membership table. Yeah?
I have two questions.
Sure.
What is the power set, and is the empty set always included in any set ever or not?
Okay, so the power set is the set of all subsets of a set. The empty set is included in a set in the sense that it's a subset of every set, but it's not an element of every set. So the empty set is always a subset of a set, but not necessarily an element of a set. It could be, but it doesn't have to be. Okay? Okay, so after sets, we talked about functions. So you need to know the definition of what a function is. You need to know about the domain, codomain, and range, what the pre-image and image of a function is or are, what it means to be injective, surjective, bijective, what it means to be countable or uncountable, what it means to compose two functions, and graphing functions. And I meant to take out the floor, ceiling, factorial stuff because we didn't do that this term, so don't worry about that last point. You can stop at graphing functions. So the kinds of questions you would see here are, what is the image of the following pre-image? What is a pre-image of the following image? What's the range of a function? Is the following function injective, surjective, or bijective? I mean, that's definitely going to come up, right? That was on your assignment and on the tests. It stands to reason I would ask about that here as well. I might give you some sets and ask which one is uncountable or which one is countable. And I might ask which of the following is the correct graph of a given function. And the trick there is almost always recognizing if it is to the real numbers or to the integers, or from the real numbers or from the integers, in which case you would either have a smooth curve or dots. Yeah?
What is uncountable versus countable?
Yeah, so it's countable. A set is countable if it's finite, or if there's a bijection between it and the positive integers. And it's uncountable if that's not true. So for example, the positive integers are trivially countable. The odd positive integers are countable. The even positive integers are countable. Rational numbers are countable. Real numbers are uncountable.
Because there's no bijection.
Because there is no bijection, right? This was the example where we said, suppose there is a bijection, then there's a list of them, and then I constructed a number that was a real number that wasn't on that list, and therefore there's no bijection. Yeah. Okay, so that's functions. After that, we talked about sequences and sums, so you'll need to know definitions, as usual, what that sigma notation means. You'll need to know about geometric and arithmetic sequences, summations, sigma notation, how to reindex a sum, how to split a sum, how to factor something out of a sum, how to work with nested summations, how to work with geometric summations, and the closed forms for the usual things. So I said you need to know closed forms for the first n integers, the first n squares of integers, and the first n cubes of integers. Those are the formulas that come in handy. Okay, so I expect you to know those. So the kinds of things you would ask, or you would be asked here is, which of the following sums are geometric or arithmetic? Which of the following sums is equal to something? So I would give you a sum and 4 choices for what it's equal to. And in that case, what you would probably do is solve it longhand and then select your answer. And what is a valid closed form for the following sum? Yep.
Or just a general exam question. Are a lot of them like kind of short answery ones compressed into just 4 options for the right answer?
Yeah, so I would say the trickiest ones are probably these summation questions because you have to do a lot of work to get a single answer. I try not to do that as much as possible, but for the summation ones it's a little unavoidable. Because I would hate to have you do like a 2-page derivation and then have one answer where it's +1 and one answer where it's +2. I don't do that deliberately, but in summations it's tricky to do it otherwise. Yeah?
Is there any reason why you don't have, why you
Yeah, that's a good question. So this is a bit of a history lesson now. So I've been doing this course since 2005, and way back then, 10 years ago, we did all short answer questions. And this was very time consuming, although back then we didn't have the enrollment we do now. So we have maybe 200 people in the class instead of the 370 we have this term. And it was a lot of work to do the exams, but it was fine. And at some point, the enrollment started to get high into like the 250s or so, and we said, you know, this is becoming a lot of work. So what we did was we had it roughly half multiple choice with 5 or so short answer questions, and the short answer questions were proofs. So you have a couple like direct, indirect proofs, and then maybe an induction question. And we did that for a while, but what ended up happening was the grades were very tightly correlated on the two. So your grade on the multiple choice part was a strong indicator of your grade on the written part. And at some point we said, well, this is silly, right? If they're getting the same grade anyway, why are we making all this extra work? And if you combine that with refining these multiple choice exams over the years, it's come to the point where, for example, all of your test grades are a fairly strong indicator of what your exam grade will be. So that's why we do this multiple choice thing. It doesn't make a difference, and it avoids a lot of problems and turnaround time that come with written exams. It's not the perfect solution, but the pros by far outweigh the cons. Other questions? Okay, so moving on. We also talked a little bit about algorithms, so you should know the definition of an algorithm, how to do linear search, how to do max finding, how to do sorting. Again, I'm not asking you to memorize the pseudocode, I'm asking you to know what the idea of these algorithms is. You should know a little bit about models of computation, so we mostly looked at the comparison model, where the only thing that counts as taking time is a comparison, so less than, equal, greater than, less than or equal, greater than or equal. And we did a little bit of analysis of algorithms. So the kinds of questions you would see here is stuff like, how many comparisons does the following algorithm perform? Which of the following algorithms performs correctly? And which of these algorithms performs faster for a given output? Now you might notice there weren't a ton of questions like this on your assignments, and there weren't a ton of questions like this on the tests. This was not a focus of the class. The only real reason I covered algorithms was to give you a bit of a preview for what you'll see in the future and to motivate Big O. So you should understand these things, but notice that it was not a focus of the course. What was a focus of the course arose from that, and that was growth of functions. So you definitely need to know O, omega, and theta, right? That was a big focus of stuff we did in this class. So you need to know the definitions. You need to know, what C and K are. You should know the growths of common functions. For example, how to figure out the growth rate of a polynomial, right? It's the exponent of the leading term that's the most important thing. And you should know a little bit about factorials and logarithms because they come up sometimes too. So you should be comfortable with them. So you'd see stuff like which of the following functions is O, omega, or theta of the given function. What are valid witnesses for the following pair of functions to be O or omega? And which of the following functions grows the fastest or the slowest? Those are the common kinds of questions. Now, the students who are paying attention will note that so if a function really is big O of another function, there are infinitely many witnesses that prove that. And because I'm asking what are the valid witnesses for the following pair of functions, I will have carefully crafted the question to ensure that only one pair of witnesses is valid. So if you think that more than one is valid, you've gone wrong. So I have made sure that there really only is one correct question or one correct answer to these questions. So any questions about what you'll need to know for growth of functions? This is okay? Okay, so after that, we started talking about induction. So you should know how induction works, the idea behind induction. It's this domino effect, right? You should be comfortable proving statements involving equalities or inequalities. So stuff about summations, for example. You should also be comfortable with structural or non-formula proofs. We did a few of those. Think tiling a chessboard with one square missing, right? That wasn't a formula proof, that was a structural proof. And Once again, I forgot to update my slides. You don't need to know about strong induction. We didn't cover that this term. That's okay if you didn't get cheated. It's exactly the same as the induction we did. It's just more complicated. So the kinds of things you would see here are things like, what is the correct basis step or inductive hypothesis for the following proof? Right, I would ask you about the proof, how it goes. I might give you a proof, take out a step, and ask you to fill in what's missing. Or I might give you an inductive proof that's wrong and ask you to identify where the error happens. Okay, so that's what you have to do for induction. So usually with induction, there's some trick that you do in the inductive case that lets you apply the inductive hypothesis. If you go through the examples we did in class, I showed you all the different tricks you'll have to learn for that. Right? So go through those examples and you'll have a good shot at figuring out how to finish these proofs. All right, then we talked about relations, and this is a big one because there's a lot of terminology that went with relations. So you need to know what the definition of a relation is, right? It's a subset of some Cartesian product. You need to know how to represent relations, so either as a set or a matrix. You need to know about reflexivity, symmetry, antisymmetry, and transitivity. Those are the 4 big properties. You should be comfortable taking the union, intersection, difference, and composition of relations, as well as computing closures, so reflexive, symmetric, and transitive closures. You should know how to do all of those. Then we talked about equivalence relations, which brought up equivalence classes, as well as partitions. And then we talked about partial orders, which bring up posets, comparable and incomparable elements, Hasse diagrams, as well as topological sorting. So that's what we covered on relations. And you'd see questions like, what is the matrix representation for the following relation? So I would give you the set representation, and I would ask you for the matrix representation, or maybe vice versa. I might give you a relation and ask is it reflexive, symmetric, antisymmetric, transitive, whatever, or maybe some combination, right? So you would say like, A, this relation is reflexive and symmetric. B, this relation is reflexive but not symmetric, and so on. Is the following relation an equivalence relation or a partial order? That would be another one. Of course, that would probably be like a true-false variety. What are the equivalence classes of the following equivalence relation? So I would give you an equivalence relation, and I would tell you it's an equivalence relation, and I would ask you, what are the equivalence classes, or alternatively, which of these 4 choices is an equivalence class? Yep.
For induction,
Yep.
in the last slide,
Mhm.
do you have any problems like that tile problem that we did in class?
Right, so, I mean, if I were just giving you that tiling problem for the first time, that would be too complicated for an exam. But now that I've shown you that tiling problem, if there's something that's very similar or the same kind of trick, I would consider that fair game. Right, so my philosophy for this course and really all my courses is that you should be challenged on the assignments, but on the tests and exams, if you've been following along and understand the material, I'm not looking to throw curveballs at you there because it's a stressful situation, you're under limited time, it's not a fair way to measure how much you understand. But on the assignments, you should be able to apply what you've learned in a more tricky situation, so that's why they're a little bit harder. Okay, so you might also see questions like what are the maximal, minimal elements, etc. So greatest lower bound, lowest upper bound, that kind of thing in the following Hasse diagram. So I'd give you a Hasse diagram and ask questions about it. So that kind of thing. And I also might give you a partial order and ask you for a compatible total ordering, in which case what you're really being asked is to topologically sort that poset. So you'd have maybe 4 options, and you would tell me the one that is properly a proper compatible total ordering. Okay, and the last topic in the course was graphs. This is another big one because there's a lot of terminology that goes along with it. So you should know the definition of a graph, right? It's a pair of sets. One is a vertex set, the other is an edge set. You should know the different kinds of graphs, so simple graphs, multigraphs, pseudographs, and all of their directed versions. You should know how to represent a graph. So we looked at the adjacency list and the adjacency matrix. There's also explicitly writing out the entire graph as 2 sets. The terminology associated with graphs, so adjacency, incidence, degree. Different classes or common types of graphs, like the complete graph, the cycle, the wheel, and the complete bipartite graph. You should know about subgraphs, spanning subgraphs, paths, circuits or cycles, same thing. about connectivity, so what it means to be connected in both the undirected and directed cases, about connected components, about trees, about spanning trees, about cut vertices and cut edges. We also did depth first search and breadth first search, and then planarity and coloring. So those are the last two topics. Now, planarity and coloring, we did a lot of complicated proofs. I'm not expecting you to be able to recite those, but you should know what it means to be planar, and you should know what it means to color a graph. Right? That's all I'm asking there. So you'd see questions like, I'd give you a picture of a graph, and I'd ask you for its adjacency matrix or its adjacency list. I might ask you to run depth first search or breadth first search on the graph, and then ask a question about what you get. Now, you might realize that there are multiple ways of running depth first search and breadth first search on some graphs, but don't worry, I've crafted the question carefully, and no matter what choice you'll make, you'll get the answer I'm looking for if you do it properly. So it might seem like you have a choice, but you don't actually have a choice. So just do it properly, and you'll be fine. What else? So what is the degree of a given vertex in a graph? Is the following graph planar? So I would draw a graph that might have edge crossings, but remember the question is really, could you draw it without edge crossings? And then the last thing I might ask is, what is the chromatic number of some graph? And remember, in general, that's tricky, right? It's hard to compute the chromatic number of a general graph, so there would be something you can take advantage of to figure it out more easily. So for example, the chromatic number of the complete graph is easy to compute, right? It's n, because every vertex is connected to every other vertex, so every vertex needs a different color. So in that case, even though in general it's difficult to compute the chromatic number, in that particular case it's easy. So it'd be something like that perhaps. Or I could ask you, here's a graph and a coloring, is it a valid coloring? Things like that. Questions about this? Yeah?
Will there be questions along the lines of, here's a graph, which ordering of the vertexes gives you the best coloring?
Yeah, I would consider that fair game if we did this greedy coloring thing. I wouldn't expect you to memorize the greedy coloring strategy. That's more work than I'm expecting. But in principle, that's okay. I'll tell you that it's not on there. Other questions? Yes?
Calculators allowed or necessary?
Calculators are neither allowed nor necessary. Other questions? Okay, so a few final words. You definitely need to settle your term grade before the exam. So I understand that assignment 4 is the exception because you will almost certainly not get your assignment 4 back in time for the exam. Sadly, they do take time to mark, and the TAs are just as busy now as you are. But everything else, so in particular test 3, which is being returned in the tutorials this week, you need to settle that before the exam. I'm not going to accept any appeals after the exam is over, except on assignment 4, because you won't have had a chance to see that necessarily. So everyone has got their tests back except the people in the Friday tutorial. Friday happens on Wednesday this week, which is tomorrow. So if you have a Friday tutorial and you want your test, you go to the tutorial tomorrow, same time, same place. If you can't make that, that's okay. All of the tests will be available in my office after the tutorial is over. So if you've already had your tutorial this week, your test is now in my office if you haven't picked it up. Tomorrow's will be in my office after the tutorial. So do take a look at that because it's important to get an idea of where you went wrong on those things. All right, so you also need to know when and where the exam is. I don't post that information on CU Learner in my slides because I don't want to be wrong and I don't want it to be my fault if you miss it. Maybe that's a bit selfish, but it's not hard to figure out when the exam is. You just go on Carleton Central and look at your exam schedule, or you go to carleton.ca/SES for scheduling and examination services. So you are entirely responsible for arriving at the correct time and place. I can basically guarantee that I will get an email from someone in this class saying when is the exam, and I will reply 2 hours ago. That almost always happens every term. Doesn't seem to matter how big or small the class is, it always happens. I can't do anything for you if that happens. You have to go to the registrar and apply for a deferral, and there's even then no guarantee that you'll get it if you missed it for a bad reason, like, oh, I overslept or I wasn't feeling up to it. So definitely talk to the registrar if that happens. You can send me an email, but all I'm going to do is say go to the registrar's office. I don't get any say over that. Okay, so when you're studying, you will probably find, or hopefully you'll find, that there aren't really any shortcuts to learning this material. One of my profs used to say to me that the only, and therefore easiest way to get a good grade in this course is to know and understand everything. And that seems like it's probably not very helpful, and I didn't think it was at the time, but in retrospect it is. Don't spend a lot of time trying to guess at the questions I'm going to ask, or trying to guess at short ways to learn the material, or something like that. You need to spend time going through the notes and understanding what's going on section by section. Take your own notes if you find that helpful. Watch the YouTube videos, go through my notes. I definitely recommend going through the tests. Right? That's really important, to go through the tests and understand the solutions. Same with the assignments, same with the tutorials. So really do go through those. That's the only way that you'll be able to understand this. There's no shortcut. You're not going to find a website the night before that lists every answer to the exam. That's not going to happen. So that brings up the next point, which is that you shouldn't be surprised. None of the questions on the tests should have been surprising to you. First and foremost, because I posted sample tests the week before. But even if I didn't, it shouldn't have been surprising. Right? I did a ton of examples proving things were injective, surjective, or bijective. It shouldn't have been a shock that you would have to do that on a test. Right? I spent a ton of time doing proofs by induction, so it shouldn't have been surprising that on a test you would have to do a proof by induction. So think about what I spent a long time on in class. That will be a focus of the exam. That will definitely come up. So always think about that. And then the last thing is that you're not alone. So I'm not leaving just because this is the last lecture. I'm going to hold my usual office hours Monday, Wednesday, 3 to 5, right up until the exam. And also, I'm going to hold extra office hours on Friday, April 17th from 1:30 to 4:30. That may or may not be the day before the exam. And that'll be just for this course. So my other two courses won't, they'll have already written their exam by then. So this will be just for you guys, that 3 hours. And you can also use the forum or See You Learn and email me. If you don't understand something, please say something, right? The answer isn't just going to come to you in the middle of the exam. I will help you, but you have to let me know. I'm not a mind reader. Any other questions about the course or what's going on in the exam? Going once? Okay, that's it. Thanks for a great semester.